Hi and welcome. I hope everyone is okay. Now, in this lesson, beforely, I want to brief summary about using the normal distribution as an approximation to the Poisson distribution. Please remember that as the last lesson, we learned about we learned to use normal distribution instead of Poisson distribution. We can use normal distribution under the some situation instead of the Poisson distribution. For example, if you want to exactly value in the probability of exactly value in Poisson distribution, you can use Poisson distribution formula. But you want to some value, a lot of value, the probability of a lot of value, you can use normal distribution under the some situation. For example, if your lambda, the other way, mean, average, 10, your curve skewed. But when you lambda value increases, your curve tend to normal distributions curve. So very symmetrical curve. And please remember that your in Poisson distribution, lambda means mu, and in Poisson distribution, your mean and standard, your mean and variance, the same value. And when you use normal distribution instead of Poisson distribution, you can use lambda instead of nu. You can use again lambda instead of variance. But please remember that Poisson distribution is discrete distribution. Normal distribution is continuous distribution. So you need to Poisson distribution convert to Poisson distribution values data, convert to normal distributions data. So you should use continuity correction. When you use continuity correction, you should use this formula. X value convert to Z value, and Z value equals to X minus nu over standard deviation. But in Poisson distribution, nu means lambda, and standard deviation means the square of the square root of the lambda, because because variance and lambda the same value in Poisson distribution. So when you use the when you want to use standard deviation, you can compute square root of lambda. So you could find the standard deviation. And please remember that we have an example. This example about Manuela posts pictures on her social media page at random points time, and she posts on average 24 pictures each week. On average, 24 pictures each week means lambda equals to 24. And when you see this section, Manuela posts pictures on her social media page at random points in time, it means we can use Poisson distribution, because our data in Poisson distribution independently and randomly. And when you see the in any question random independently, such as these words, so you should think about this question regards to Poisson distribution. And if you're a lot of value, if you need to find the probability of a lot of value, you should think about you should use to the normal distribution instead of Poisson distribution, because while using Poisson distribution formula, to figure out these section very hard, but in the normal distribution very easy figure out very easy. Okay, when do you use normal distribution instead of Poisson distribution? Your lambda, for lambda greater than 15, the Poisson distribution with mean lambda can be reasonably approximated the normal distribution with mean lambda and variance lambda, the same, with a continuity correction applied. The accuracy of the approximation improves as lambda increases. So we have an example. Manuela posts pictures on average 24. So lambda greater than 20 or greater than 15, and we can use normal distribution instead of Poisson distribution. And please remember that we solved the first section, the exact value x, the probability of x exact 30. We figured out both Poisson formula and normal approximation, and we could find very similarly values, both Poisson formula and normal approximation. And we have another section, this section about the probability of x between 29 and 31. Okay, now I want to pass the next page, and we want to compute the probability of greater than 29 and less than 31. And if you want to the probability of x greater than 29 less than 31. Firstly, please notice that 29 means this point, the middle of this rectangle, and 31 is this point, the middle of this rectangle, rectangle. And I want to use the bigger graph, and 29 this point, as I said, and 31 this point, and you want to compute exactly greater than 29, but in the normal curve you should find this area. You should find this area. So this rectangle bounds is 29.5. So you should find greater than 29.5, and this point is 31. But in the normal curve, the normal distribution curve, the rectangle bound is here. So this point is 30.5, and you should find, if you convert to the normal distribution, you should find the probability of x value greater and equals than 29.5, less and equals than 30.5. And step 2, you should make a continuity correction, and you should use this formula. Z value means x minus nu, in Poisson distribution nu means lambda, and the square of lambda, means standard deviation. So because we should use z table, and we should find z values, and we should compute that z value greater and equals than 29, also means x, and minus lambda. Please remember that in this question lambda is 24, and the square root of 24, less and equals than x 30.5 minus 24, and the square root of 24. And I want to look at the solution table. This section equals 1.327. 1.327. It means the probability of z less and equals than 1.327, and the other section equals to 1.123. So greater and equals than 1.123. And if you remember that the normal distribution curve, very symmetrical, it was very symmetrical curve, and the curve means equals to 0, and 1.327 here, and you want to less and equals than 1.327, and 1.123 is here. 1.123 is here, but you want to find greater and equals than 1.123, greater and accused than 1.123. So you should find the range of the these area, the interval of the these area. Okay, as you remember, when you use the normal distribution and look at the phi 1 to 1.327, you can find the big area value. And if you look at the Z table and 1.123 value, 1.123 value, also it means phi 1.123, you should find a big area value. The big area means that. Because this is 0 and 0 is the middle of the this curve. So if you look at the phi 1, 2, 3, you should find the big area. Okay, now look at the table and 1.327. 1.3 is here and 1.312, but we have digit of 7. It means 11 because 7 is here, and if you look at the last digits value 11, and this value according to 1.32, but if you want to 1.327, you should find 0.9066, but this value about this value for 1.32, but for 7 digits you should add 11 because the last of the digit 7 we should add 0.0011. So 0.0011 means 0.9077. Okay, and before we will find 1.12, 1.1, 1.12 here, but for the last digit also it means 3. For the last digit 3, we should find 3 column, and it shows us 6, and we should add the 0.0006 this with this value. So it means 0.8686, 0.8686, 0.8686, and for the last digit it also means 3. We should add Please remember that it shows us 6, so we should add 0.0006 and becomes 12 and 1 carry on the 8, 9, 6, 8, 0. 0.8692. 0.8692. Okay, now we could find this section. We could find this section, this area, and we could find this area, but we want to find between these points, so if you subtraction this area minus this area, you can find between these points. So if we want to find this area, we should compute that 0.9077 minus 0.8692, and it's also 5, 8, and 3, 0, 0. 0.0385. 0.0385. And if you look at the solution table, the same value, the 0.0385. But if you solve this problem by using Poisson distribution formula, between 29 and 31 value is 30. So you should have been 30, the probability of 30. So you could find this value, and one more time we could see these values are very similarly each other. And if we want to the range of values, the probability of range of values, we should use the normal distribution. Okay, now the other page, and we want to compute the probability of x greater and equals than 24, less and equals than 26. But please remember that this range about Poisson distribution. If you want to work on the normal distribution, you should change boundaries, because 24 means these the middle of this rectangle, and 26 means the middle of this rectangle, and but in the normal distribution, the start of the rectangle bounds is here or is here. Please, blue line. Please look at the blue line. But 24 point is here and 26 point is here. But this point according to this point related to regards to Poisson distribution. But if you go to the Poisson distribution, when you go to normal distribution, you should use rectangles bounds, and you want to find 24 accused and greater than 24. So you should convert to 24. You should convert to convert to 24. You should use these rectangle bounds. So it means greater and accused than 23.5, because greater than 23.5 convert greater than 23.5 include 24. And if you want to include 26, you should use 26 point, because less than 26.5 include 26, because we have accused. Please notice that we have accused. So while pass to normal distribution, we should find the probability of greater and accused to 23.5, less and accused to 26.5, because we want to include 26, we want to include 24. Okay, and we need to x value convert to z value, because we will use z table. And if you want to convert z value, so you should use the probability of z greater and accused than, less and accused than, x 23.5 minus lambda over the square of lambda, and 26.5 minus 24 lambda over the square root of 24. Okay, now for result, I want to look at the table. Please look at again 26.5 minus 24 over the square root of 24. 23.5 minus 24 over the square root of 24. It means 0.51 and 0.102. 0.51, the result of this part means 0.51. The result of this part 0. I want to look at again 0.102. 0.102. 0.102. Okay, now I want to the probability z value greater and accused than 0.102, less than 0.51. And please notice that the normal distributions curve, it means 0, the middle of the curve, 0, 0, and the minus, it means minus this, because when you subtraction to 23.5 minus 24, it should be negative, and 0 point negative 0.102 greater, and 0.51 less, and you should find between these points. And please remember that when you look at the Z table, it means when you look at the phi 0.102, also negative, negative 102. Every time you can figure out the big area. And negative 0.102, the big area, the right of this point. So when you look at the Z table, 0.102, you should find the big area. Okay, and when you look at the Z table and 0.51, you should find the left of this line. So because the left of this line is big area. Okay, and you want to find between these points, and the Z table shows you this area. The Z table shows you this area, but you want to figure out between these points. Okay, now before I want to find 0.51. 0.51 means 0.5, 0.51, 0.695, 0.695, 0.695, and 0.102, 0.102, 0.10 means this value, but we have extra 2, the last of the digits, extra 2 shows us 8, so we should figure out the 0.5398 plus 0.0008, because the last digit 2 shows us 8, and it means 0 excuse me, 0, 4 and 5, and it means 0.5406. Please remember that under the normal distribution curve area equals to 1, and if you figure out the sum of the this value and this value, this value, and -1 you can find between these points. So beforely I want to figure out the 0.695 plus 0.5406 and -1, it means 0.23 excuse me, 0.2356, 0.2356. Okay, I want to look at the solution table. 0.2356 and rounded 0.2356, and for the last digit, according to for the last digit, rounded this digit 0.23, it becomes 6. Okay. Now we will look at the other problem about Poisson distribution and the normal distribution. We have a problem. This we want to find the probability of exactly greater than 19 and less and accused than 21. And please remember that 19 means the middle of this rectangle. 21 means the middle of this rectangle. But rectangles regards to Poisson distribution. But you want to pass normal distribution. So this point, the middle of the rectangle, this point 19, but we have no equal. So we don't want to include 19. Because of we should use 19.5 the bounds of this rectangle. 19.5, because we have no equal and we don't want to include 19. So we should use x greater and equals than 19.5. But for this bound, for the upper boundaries, also 20 means 21. 21 here, but we want to include. We want to include 21. We should use these bounds or these bounds. But if we want to include 21, we should use 21.5, because 21.5 less than 21.5 includes 21. So greater and less and accused than 21.5. So second step, we should make continuity correction. Also we should convert to z values, and it means the probability of greater and accused than z, z, and less than Z. It means 19.5 minus lambda over the square of lambda means standard deviation. 21.5 minus lambda over the square root of 24. It means standard deviation. I want to look at the table for the result of this section. 19 minus 24 over the square root of 24 minus 0.919 minus 0.919 and the other result of this part minus 0.51 minus 0.51. Okay, and I want to use the normal curve, and I want to sure which they want us area. This line means 0 because the middle of the curve 0 in the normal distribution, and minus 0.919 here, minus 0.51 here, and we want to greater than minus 0.919 and less than minus 0.51. Also we should figure out the these area. But when we look at the Z table, also every time we can find the big area. Please remember that minus 0.919 these point the left of these points big area, and phi minus 0.919 should be accused phi positive 0.910, and it means big area. Okay, 0.919 0.91 here, and also addition we should find 9 for the last digit. 9 shows us 23, and we should figure out the 0.81. I want to look at again 86, and the last of the digit 9 showed us 23. We should add 0.0023 and also 0.8206. Okay, and the secondly, I want to find 0.51 also means negative phi negative 0.51, the same positive 0.51, and the z table in the z table 0.51 value shows us the big area value. So I want to find 0.51, 0.51, 0.51, 0.695, 0.695, 0.695, and we could find this area yellow. It means 0.8206, and we could find this area, big area. It means 0.695. If you this point or this area minus this area, you can figure out the between these points. So this area means 0.8206 minus 0.695, and the last digit is 0, and 6521. So our result is 0.125, maybe round, if we want to round for the last digit. So 126. Okay, I want to look at the this part 0.126. We could figure out the result according to normal approximation. If we figured out according to Poisson distribution, we could find 0.134, and it's please notice that these values are very similar each other. Okay, now in this for now this lesson finish.